Um, my name is Ryan. I am a PhD candidate at SUNY ESF. My work is titled Regional Total Phosphorus Prediction Without Temporal Aggregation or Imposed Model Structure, a Multi-Site Spatio-Temporal Framework. Regional nutrient prediction often relies on temporally aggregated data and models with an imposed structure. And aggregation of this type of data discards information, and it makes assumptions about how watersheds and concentrations work. The real world monitoring networks will produce irregular, asynchronous, and spatially heterogeneous discrete observations that are poorly suited to this type of aggregation. And so the gap this study fills is whether spatiotemporal models can leverage this type of data for prediction at unmonitored sites, and whether model structure influences what we learn about nutrient drivers. For this study, we gathered close to 10,000 discrete total phosphorus samples across 54 watersheds from the year 2000 to present. And so in this bottom figure, you can see that there's irregular sampling frequency and the sampling periods are asynchronous across sites. So we built models with predictors from four categories. We had discharge, static watershed characteristics, daily hydrologic and seasonal, cyclical seasonal signals, and then we had annual agriculture and management pressure. We tested two modeled classes, linear regression and random forest, and each were fit across formulations of the predictors of increasing complexity from temporal only predictors to a full spatio-temporal model. And our models were trained using cross-validation, where entire sites were held out to simulate monitoring modeling at unmonitored locations. So the framework generalized to unmonitored sites. The random forest had explained 58% of the variability, while the LM explained 44%, which is relevant in the literature of meaningful skill using this type of irregular discrete sampling. The performance showed no relationship with number of observations per site. The predictions tended to converge towards the network mean for both models. But including of the spatial watershed characteristics helped convert those means towards more of a site mean, and the RF took better advantage of that. And the RF outperformed LM across all formulations and the valuation metrics. And both models recovered a similar signal about the dominant drivers of nutrient export. The spatial predictors drove the larger performance gains. And the agricultural corn signal we found reflected a contrast between agriculture and non-agricultural watersheds rather than within site temporal variability. And so this framework offers an alternative to SWOT, which is our current approach for nine element planning. Um, yeah,